Okay, you guys, we're going to put it all together now and we're going to write our paragraph. So remember, we've got a topic sentence and a concluding sentence, and then we're going to do 3 observations and 3 explanations. I'm going to start the first one with you, and then you're going to do 2 and 3 on your own. So as far as the topic sentence goes, we want to make sure that we're answering the question. So up here we have our purpose. So we wanted to observe and describe the effect mass and velocity have on momentum. So we did the observation part in lab. We saw what happened to that cup when the ball hit it at different velocities and the different masses of the balls. But now we want to describe that effect. So you answered analysis questions 1 through 8, which helped you kind of look at different trials and get a feel for how the momentum was changing. So when I write my topic sentence, I want to describe that relationship. So I want to use keywords from the question to answer. So I need to make sure that I use momentum, mass, velocity, and then I can use increase or decrease. So I'm going to say, as the mass and velocity of an object increases, its momentum, and this is where you guys need to fill in with increase or decrease. So as the mass and velocity of an object increases, its momentum either increases or decreases. So when you rolled that ball faster, was it harder to stop? Did it increase? Or was it easier to stop? Did it decrease? From all of our data, we should all have the same answer to our question. Okay. Now, how we describe that is going to be a little bit different. We want to make sure that we talk about both mass and velocity. And so first I'm going to talk about how the mass affects the momentum. My second set, I'm probably going to talk about how the velocity affects the momentum. Then I have a third set, and I want to pick just another example to illustrate my idea. It can be of mass or of velocity, or it could be a combination of both. Maybe it's your heaviest and your fastest trial. So where are we going to get this data from? I'm going to go back to data table 2, and I'm going to look at my measurements here. So if we wanted to know what happens to the momentum as the mass increases, what 2 trials should we use? And obviously they're marked here already. I want to use, if I'm trying to look at mass, 2 trials that their mass is different, but the velocity is the same. I want to change one variable and keep the other one the same. So I'm going to use my wiffle ball that rolls slowly, that has a velocity of about 0.4348. And I want to use my tennis ball that rolls slowly that has a velocity of about 0.3. But my masses are different. It's about twice as much, that tennis ball. So when I look at these, I see that my momentum also about doubles. It goes from 0.012 to 0.025. I want to use those exact values in my conclusion sentence, or in my conclusion. So when I go back to my observations, I'm going to choose a sentence starter. I'm going to say, I know, for example, in lab, or to illustrate in lab. I'm going to start with I know, and I know that the mass, I know that a higher mass object is going to have a larger momentum, because in lab, I slowly rolled a wiffle ball that weighed, how much did my wiffle ball weigh? 0.02756 kilograms. 0.0257 kilograms. And it had a momentum of, notice you guys, I'm using values, which seems weird in writing, but in science it's totally fine. 0.0120. 0.0120 kilograms times meters per second. Now, if I want to show that increasing the mass changes the momentum, I need to have a second thing to compare it to. So this is a long observation. So I know that a higher massed object is going to have a larger momentum because in lab, I slowly rolled a wiffle ball that weighed 0.0257 kilograms and it had a momentum of 0.0120 kilograms. When I rolled a heavier ball weighing, how much did my tennis ball weigh? 0.0586 kilograms, my momentum increased to 0.0251. 0.0251 kilograms times meters per second. So you guys, in your observations, you want to make sure that you're making a comparison. So I'm talking about what happens. I'm focusing on mass and momentum here. So I'm just looking at how mass affects momentum. And then I am giving some really concrete values. So I'm talking about my wiffle ball's mass and its momentum, and then my tennis ball's mass and its momentum. And I can clearly see that the higher mass gives us a higher momentum. But now I need to explain why that's important. So I'm going to go on to my explanation here. And I want to choose a new sentence starter. I'm going to say this proves that an object with a higher mass is going to have a larger momentum because when I rolled the heavier tennis ball, here's where there's a really important part. We need to prove that it was the mass that was affecting the momentum. So I need to show that my second variable, the velocity, stayed the same. So this proves that an object with a higher mass is going to have a larger momentum because when I rolled the heavier tennis ball and the lighter wiffle ball with the same velocity, the tennis ball had more momentum. So I proved what my relationship was. The higher the mass, the larger the momentum. But I also made sure to show that my data was just looking at the mass by mentioning that the velocities were the same. So like I said, you guys, you're going to do this 2 more times. You're going to next write about your relationship with velocity and momentum. Then you're going to choose a third example, something else that really stuck out to you that you didn't have an opportunity to talk about. A lot of students in the past have chosen to talk about their heavy trial, their tennis ball, quickly because it shows both variables, and most people had this as their largest value. So you can look at that relationship. If you have any questions, feel free to ask. Otherwise, make sure that you are using sentence starters, you're checking your spelling, your punctuation, and really making sure that what you're writing makes sense and is detailed. Use those scientific words and prove that you understand what was happening in this lab.